Hi everybody, I hope you are doing well. Today, I will explain the classification of polymers. Have several factors by which the polymers can be classified. So polymers can be classified according to their origin, their thermal response, their structure, the line structure, and several other factors can be used to classify the polymers. According to the origin, the polymer can be natural, synthetic, or semi-synthetic. Natural is the polymer that exists in nature without any synthetic process to produce it, like the, the proteins, like the carbohydrates, the rubber, the wood. All of these are natural. Synthetic are those polymers that are totally synthetic. They are prepared chemically, like the plastic polymers. Semi-synthetic, which is part is natural and the other part is synthetic. So natural is available in natural, that's natural rubber, natural silk, cellulose, protein, starch, lipids, carbohydrates, all of these are natural. And semi-synthetic are man-made, for example, hydrogenated and halogenated, and the cyclorubber and cellulose ester. So it depends to somewhat on the natural, uh, on a natural part, and we add something which is synthetic to improve the quality of that natural polymer. Synthetic is man-made, like the polyethylene, the polypropylene, the polystyrene, the polycarbonate, the epoxy resin. Classification according to the thermal response. How these polymers behave when they are heated or cooled. We have two types of polymers according to the thermal response, which is thermoplastics and thermosetting. So the thermoplastic polymers, they melt on heating and harden back on cooling. Like the plastic. If you heat the plastic, a plastic rod, a synthetic, a synthetic plastic can, for example, when you heat it, it will melt it, and when you leave it to cool down, it will harden again. But they retain their solubility and diffusibility over many cycles of heating and cooling. So it means that they are not changed chemically upon heating or cooling. Only its state, its physical state, is changed upon heating and cooling, while the chemical properties remain the same. For example, the polyethylene, the polypropylene, the polystyrene, and the polyester, all of these are thermoplastics. While the thermosetting, they are hardened by heating or radiation. As we heat it, it becomes harder. If it is exposed to radiation, it becomes harder instead of melted. That because upon heating, there is a cross-linking happen between the polymer chain to produce infusible and insoluble polymers. So the structure of the polymer is changed by heating and radiation. That's why it becomes harder, like the resins in example, in general, like phenolic resin, amino resin, epoxy resin, and unsaturated polyesters. The mode of formation classification, depending on the mode of formation or the mechanism of reaction, we have a chain growth and a step growth reaction. A chain growth is a way of addition polymerization where every monomer is added in sequence to the other to form a long chain. This is a monomer. The chain growth and is a reaction mechanism where after the addition of each monomer, there is the active site to attract one more monomer. And in that way, the chain will become larger. So it's called the addition, chain growth addition polymerization. Step growth is that there are a step-by-step growth. So if in that case, in that we have bifunctional or multifunctional molecules, they form oligomers. So they bound together in oligomers. And then these oligomers are added to this. Anyway, we will explain in more detail the mechanism of polymerization, and we will know in details what is every type of that reaction of this way of polymer formation. So examples of a chain growth or addition polymerization, like the polyethylene and other polyolefins, polystyrene, and related vinyl polymers. Examples of a step growth or condensation polymerization, the polyesters and the polyamides. As you can see, there is a functional group in each one. Polycarbonates, phenols, urea and melamine, formaldehyde resin, and the epoxy resin. Classification according to the line structure, the structure of the uh, backbone of the polymer. It can be linear, branched, or cross-linked. Linear polymer is a polymer where there is no branches that come out from the backbone, like the high-density polyethylene, HDPE, polyvinyls, bifunctional polyesters, and polyamides. So it will be linear. No branches will emerge from the chain. While the branches, there are some branches that emerge from the linear chain. So this branch cross-linked, the branch form cross-linking with other chains of the polymer, forming this cross-linked chain. Branches, they have branches like the low-density polyethylene, LDPE, and the higher polyalpha olefins. The cross-linked or network have a complex network structure like a web structure, like unsaturated polyester resin and cured epoxy resin. To wrap up what we have said today, the polymers are classified depending on many factors, such as their origin, whether they are naturally occurring or synthetic, developed by chemical reaction, which is polymerization, or semi-synthetic. They can be classified according to their thermal response. Some of them can be melted by heating, and this is called thermoplastic. It's elastic in under under temperature because they melt when heating and harden back when cooling down, and they never lose their solubility and fusibility properties if they are heated many times, if they underwent many cycles of heating and cooling. And the other type is thermosetting, and this is the opposite. This type of polymer is hardened by heating. As we heat it, become harder. Why? Because it forms cross-linked polymers, which make it harder, which affects its solubility by heating. They can also be classified, polymers can be classified according to the mode of formation, how the polymerization reaction takes place to form these types of polymers. We have two types, addition or condensation. Addition is called the chain gross polymers or chain gross polymerization, and condensation is step gross polymerization. The chain gross is an addition reaction where monomers are added gradually to the chain, and the chain becomes larger in three main steps: initiation, propagation, and termination. We will talk more in details about polymerization. While the reaction takes place in smaller steps. So first, oligomers will be formed, and then oligomers will bound together to form polymers, and this is specific for the bifunctional or multifunctional. Polymers can also be classified according to their backbone structure, whether this backbone is straight, linear, or there are some branches that emerge from the backbone, or maybe there is a formation of web or network structure. So it can be linear, branched, and cross-linked. That's all, guys, for today. Thank you so much for watching, and see you in the next video. Follow me, and bye-bye.